This problem is dealing with a proportion. Now, a proportion has to be a proportion of something. You have to come up with a characteristic, basically a binomial characteristic. Either it is or it isn't. And so there's no way for StatCrunch to be able to predict what we're going to be looking at. We could be looking at the proportion of integers in the set. We could be looking at the portion of fractions. We could look at the proportion of numbers that were larger than 12 or smaller than 3, all kinds of things. So that could be anything we pull out of thin air. It says 3 randomly selected households are surveyed. The number of people in the households are 2, 6, and 7. So our population here is the set of numbers 2, 6, and 7. Assume that samples of size n equals 2 are randomly selected with replacement from the population of 2, 6, and 7. Construct a probability distribution table that describes the sampling distribution of the proportion of odd numbers. Okay, so this is our choice of what we're going to look for a proportion of. The proportion of odd numbers when samples of sizes n equal 2 are randomly selected. Does the mean of the sample proportions equal the proportion of odd numbers in this population? We want to know. Does the mean of the sample proportions, that's p hat, equal the portion for the population? So we have to get the p hats, which will be the proportion for each sample, get the mean of those 9 numbers, get the proportion for the population and compare the two, and the proportion we're looking at is the proportion of odd numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Here are our samples. I'm going to go ahead and load this into StatCrunch, even though StatCrunch cannot calculate the proportions for us, because this way StatCrunch can calculate the mean of the proportions for us. So if I label this column proportions of a 2 and a 2, that is 0% odd numbers. So that's a 0. 2 and a 6, no odd numbers. 2 and 7 is 50% odd, so 0.5. 6 and 2 is 0%, 6 and 6. 6 and 7 is 50% odd. 7 and 2, 50%. 6 and 7, 0%. 7 and 7 is 100% odd numbers, so that's a 1. So my proportions are either 0, 50%, or 1. So 0, 0.5, and 1 are the possible proportions here. The probability of having 0%, I've got 1, 2, 3, 4 out of 9. 50%, there's 1, 2, 3, 4 out of 9. 100%, 1 is 1 out of 9. Clear this out so we can see. Good job. Now, they want us to compare the proportion of odd numbers in the population. Okay, remember that the population consists of the numbers 2, 6, and 7. So 1 out of 3, the proportion of the odd numbers here is 1 out of 3. The mean of the sample proportions, let me get StatCrunch to do that for me. I want to do the mean of the column. So summary stats, columns. I want to do the mean of the column with the proportions. The mean is 0.33333. So the mean of the p-hats is 0.3333. 1/3 we know is 0.3333. So they are the same. So the proportion of odd numbers in the population is equal to the mean of the sample proportions of even numbers. Nope, that can't be right. The proportion of odd numbers in the population is not equal. That's not right. The proportion of even numbers. We're not even talking about even numbers. The proportion of odd numbers in the population is equal to the mean of the sample proportions. Ah, yes. Okay. The sample proportions do not target, wrong. The sample proportions target the proportion of odd numbers in the population. So sample proportions do not make, oh no. The sample proportions do not target, oh no. The sample proportions target the proportion of odd numbers in the population. So sample proportions make good estimators of the population proportion. Ah, yes. Good job. So this isn't that bad. You have to super keep track of what you're doing and why you're doing it. On the variation and the standard deviation, you have to correct the population variation and standard deviation because StatCrunch only gives sample standard deviations and sample variations. So regardless of which one they're asking for, when they ask about the population, I would go ahead and get the variation, multiply it by the number of samples minus 1. So if there's 9 samples, multiply by 8. If there's 16 samples, multiply by 15. And then divide by the number of samples altogether. So you'll multiply by 8 and divide by 9, or you'll multiply by 15 and divide by 16. And then if it's standard deviation, go ahead and take the square root then. You only need to correct the population statistic. For variation or standard deviation, everything else is up front. After you get the statistic for the samples, and you do that by hitting the row instead of the column. After you get the statistic, you're going to need to copy that back into StatCrunch and then get the mean of that column. Got it? Keep track of what you're doing. Let me know if I can help. I'll talk to you later.